All right, so let's get started here. Like I said, we are in our same unit, so we're still in taxonomy. We're in the animal kingdom now. But we just finished up last week talking about invertebrates, animals without backbones, and each of them was in a different phylum. But now we're going to start to talk about vertebrates. So, what is a vertebrate? What does that word mean, Matt?
An animal with a spinal cord.
Yeah, an animal with a backbone, we'll say. And so vertebrates are in kingdom animal, and they're in a phylum called chordate. And then within the chordate phylum, there are vertebrates. Vertebrates really a subphylum, but. And so when we were talking about invertebrates, some of the invertebrates, like the arthropods, what was the term for their skeleton? Exoskeleton, meaning what?
Outside.
Outside, a skeleton on the outside. Well, vertebrates have a skeleton, but it's where?
Inside.
Inside. The term for that, sort of the opposite of exo, is endo. Endoskeleton. It's like endoscopy is when they use a camera to look into a person's esophagus and stomach. And,
Shove that out my dad's nose.
Oh, really?
Yeah.
So when we think about vertebrates, we're going to talk about 5 main groups. Most are classes, really. And so, what are the classes of vertebrates? What is this? Fish.
Froggy.
Well, what is it?
Amphibians.
Amphibians.
Reptiles.
Reptiles.
Birds.
Birds and
Humans.
You're
No.
going too fast.
Primates.
Mammals.
Mammals.
Bam.
So those are our 5 groups of vertebrates that we're going to talk about. Okay, fish, amphibians, reptiles, birds, and mammals. What we're going to do basically is take each one at a time, talk about some of their characteristics that they have, some adaptations, some examples, maybe watch Brain Pop about them, watch some videos, just so we can understand these different types of vertebrates a little bit better.
Yes, they're doing. Don't we dissect the frog?
Not in this unit. Next unit.
Later.
Oh, next one, right.
All right, so let's start off with fish today. So we're all familiar, obviously, with fish. How many people in here go fishing regularly? Oh, so a fair number of you. So you'll know a little bit about these. So, anybody go fishing recently? Catch a fish? Yeah?
Catch a fish ground.
Okay. So, fish have a body covered in what?
Scales.
Scales. And if you think to different fish that you may have held or seen up close, sometimes those scales are very big and they're obvious, like a bass. Like if you look at it, you could see each of the individual scales. But other fish have very small, very fine scales, things like maybe a trout, where it almost looks like a smooth skin. So there are some differences in those scales. But those scales are their outer layer of protection. And they all overlap. The scales overlap with each other. Kind of like on your roof, when you put on shingles on a roof, they all overlap to protect your house from rain and snow. Well, in a fish, those shingles, or those scales, they overlap, providing a barrier between the outside and the inside of the fish.
Where's the draws? Can't certain scales, can't they, in defense, can certain fish scales, harden?
Yeah.
So where enemies try to bite them?
No, some are harder than others, but they don't harden, at a certain time.
I
They're just
had one fish
harder.
try to bite me.
Yeah. And these scales, if you've ever picked up a fish, you may know, they also secrete a mucus. That's why fish are slippery, kind of slimy when you hold them. They produce a mucus that helps them sort of move through the water efficiently, also provides a barrier against bacteria or other things. Yeah?
The hagfish?
Yep.
Those things are awesome.
Yeah. The hagfish are sort of unique in their own sort of
What are
group of
hagfish?
fish.
Their
So,
head.
yeah, it's a type of fish, a very primitive fish. Matt? Sometimes, yeah. Yeah, they come off. You can actually look at a scale of a fish under a microscope, and you'll see it's built up in layers. You can actually use those layers to see how old the fish is. because just like a tree grows more in the spring and summer than the winter, and you can see the rings when you cut through a tree, you can do the same thing with fish. They grow more in the summer, and so if you look at a scale under a microscope, you can count back and see how old it is.
Are the rings on a tree accurate for all?
Yeah, they're pretty accurate, yeah. Scientists use that to date trees. They take a core sample.
How does it like grow a ring once every year though?
Just because it's like,
Grows
if you think about it, in the warm summer days with lots of sun, the tree grows a lot. And then in the winter, it only grows a little bit, so you could get a gap. You get sort of where the growth rings are much smaller, and you just count that it's each season. It grows, so the tree grows out, and so in the summer, it grows a lot, and in the winter, it just grows a little bit. And you could see the distinction between those seasons when you, if you like cut a tree down and you look, yep. Or if you take to look at a living tree, they take a core sample, they drill into it, pull it out, and then they look at the score and they can count the rings from the inside. But you can do the same with the scales of a fish.
Like we used to have a tree on our street for 200 years, and you know that it was there for 200 years because like when my dad was a kid, like his grandpa told him about how he first built the tree, and they just chopped it down, and I like saw it.
Oh yeah.
I didn't try to count because
Yeah. And Mrs. Dowling, she has like a section of a tree about this big, and you can see the rings in there. Another interesting adaptation lots of fish have is a pattern of coloring that's called countershading. Countershading is when an animal has dark colors sort of on the top, the back side, and lighter colors on the belly side. This is common in fish, but also in birds. Can anyone guess how this is a helpful adaptation? Olivia? Yeah, that's part of it. So that would be why they're dark on top. So that if an animal's looking down a predator from above, it blends in with the ground. What else, Matt?
Oh my god. A bigger fish was looking up. The sun looking away and blending on the side.
Yeah, a predator looking from below at the light underside would see it against the sky or the reflection above the water, and it would blend in a little bit better there too. So it allows them to have camouflage both from above and below.
what about the side?
Not so much from the side. So here's an example. Obviously, this is a salmon. You can see it's darker color on top, lighter on the bottom, and that's counter shading. And it's also here's another example: a guy holding a salmon.
Why is his mouth?
I'm not sure why he's covering his wife's face up with the
That's
salmon.
his wife.
I guess.
She looks a bit, he
I-
looks a bit
maybe
young
he's
for her.
maybe he's more proud of the salmon than he is of his wife. I'm not sure what's going
Or
on.
maybe that's his grandma.
Maybe.
Maybe that's his mom.
Why is that mouth weird?
You could read into it whatever you want. Here's another example, although this isn't a fish, but this is another animal with
It's a whale.
counter
It's a
shading.
penguin.
It's a penguin.
It's a penguin. A penguin is what?
It's a whale.
A bird. A bird.
But whales.
So yeah, some whales have counter shading, and so we have again the light underside and the dark top side providing better camouflage.
Laser.
I read this article that it's not radiation, but their skin and body, just like jellyfish, can change color to communicate.
Oh really? For fish?
They glow.
I've seen it. I've seen it.
It's not
All right, let's talk a little bit about some other factors. So body temperature. We'll talk about body temperature as we go through every group of vertebrates. What are the two words we use when describing an animal's body temperature, Allie?
Warm and cold-blooded.
Warm or cold-blooded? Now, those really aren't the best terms. There's other words that are better, like endothermic and ectothermic, but we're going to stick with warm and cold-blooded. So, what are fish? Warm or cold-blooded? Ava?
Cold.
They're cold-blooded. Now, there are exceptions though. So I'm going to say fish are cold-blooded, but there are some fish that are not. So just keep that in mind. I don't want to tell you the wrong information, but for our purposes, we'll say fish are cold-blooded. So what exactly does that mean? It doesn't mean that their blood is actually cold.
They're adapted to cold.
Not so much they're adapted to cold, Hannah.
Their body temperature changes with the temperature around them.
Yeah, it's that their body temperature changes depending on their surroundings. They can't maintain a body temperature internally. So right now, at the bottom of Oneida Lake, in the lake, underneath the ice, there's fish. And those fish are alive. But the temperature of their bodies is very low, just above freezing probably. And so because their body temperature is so low, all of their body processes basically slow down. So they breathe very little, their heart rate is very low, they're not moving, they're not very active. And so they won't become active until in the spring when the water warms up, their body temperature warms up, they can start to be much more active. Okay? Cold-blooded organisms, they can't live in extreme conditions as well as warm-blooded animals. Okay? But there's a benefit to being cold-blooded. Does anybody know how it's helpful to species to be cold-blooded? CJ?
It helps them, if they were trying, I don't know how to put it, if something were to, just suddenly, surprise them and
No. Matt?
they can survive more extreme conditions.
No, they can't really. They can survive in less extremes than warm-blooded animals.
Say somehow they get moved to someplace else. Say if it's stuck to the bottom of the
Uh-huh.
boat or something and it goes farther away, they
Not
can
so much.
adapt to it.
Let's think about those fish at the bottom of the Oneida Lake, keeping very low breathing rate and heart rate. What do you think they don't need a lot of right now? Food. Takes very little energy to maintain them because they're not making their own body heat. Whereas warm-blooded animals need lots of energy to keep their body temperature at an elevated level even if it's cold outside. So it allows them to conserve energy. You have a question, Dan, about that?
So, you're saying that fish can adjust their body?
They don't adjust, no, whatever the water is, that's their temperature. So they don't have control over it. They're at the mercy of the environment.
But I had a goldfish or something one time, and I changed the water in it to a colder
And it died.
amount by
Yeah.
accident, and it died.
They can't withstand sudden changes sometimes could interfere and are not able to change the body temperature to interfere. And some are able to live in colder weather. Alright, we gotta finish these two sides here. Alright, lateral line is an organ that the fish has. And if you look at a fish closely, like this fish here, do you see what we might call the lateral line?
Yes, I see
right
it's
there.
right there,
Right
little
here.
skinny thingy.
Yeah, that is a sense organ in fish. It's sensitive to vibrations and motion. And so in the water, the fish can sense if there's other fish nearby, there's predators. It's also one of the reasons fish can swim in huge schools of fish and all sort of coordinate their movement because of this lateral line helps them sense the movement of fish that are nearby. Okay, last one. I want to finish this. Hold on. Fertilization. We'll talk about this with all of our groups of animals. So, fish, how do they reproduce? That's what we're talking about. They have something that's called external fertilization. It's called spawning in fish. And what that means is that female fish, which lay eggs, will release those eggs outside just into the water. Male fish will just release sperm into the water. And if those egg cells meet those sperm cells, they become fertilized, they can then start to grow into embryos and eventually hatch into baby fish. That's external fertilization. We're going to talk about other groups of animals where that happens inside the body. No, they coordinate. So the male fish will generally release sperm cells right when the female fish releases egg cells. So it's around the same. It's not like just random anywhere. Because then it would probably not happen. They wouldn't be.
So, are they asexual?
No, they're so sexual because there's two. They're mixing of sperm cells from male fish and egg cells from the female.
I love that.
What? It's a evolutionary rumor.